Hi guys, I want to finish things out in our example by getting us to this second part of the fundamental theorem of calculus. Okay, I'm asking you to find the definite integral from 2 to 3.5 of little f of x dx. Well, so far what you've done, if you were just getting that particular one, let me erase some of what we've been doing here. So far what you've been doing, if you were going to just get that particular one, is you would add up your net area. So I'm getting 0 from 2 to 3, and then my net area here, it's a negative, right? So it's a negative 120 for half an hour. So it would be negative 60. So you've been using that yellow method. You've been saying, here I'll put yellow method here, accumulation of net area. You've been saying that this is equal to negative 60. You've been doing it already. But now we have this nice antiderivative up here. I've labeled it big F of x, right? So with big F of x, we can go and say, okay, what we can do by the fundamental theorem of calculus is take big F of b, okay, so that's big F of 3.5, that's our end one, right, minus big F of a, okay, that's our beginning one, 2, and that should give us that same negative 60. Now let's see. Big F of 3.5. Well, big F of 3.5 is, well, actually, no, this is blue. I'm going to mark it in red. Big F of 3.5 is right here, because here's my big F, right? My blue line. So big F of 3.5 is 0. Okay, and of course, we know his velocity at time 3.5 was 0. So big F of 3.5 is going to be 0. I'll go back to blue. Okay. Big F of 2, my y value is 60. I got that constant function 60 up there, right? So I got 0. We'll just go with, hang on, Maximus, all right. We've got 0 minus 60 is minus 60. And notice it ties, right? And it will always tie. That's the fundamental theorem of calculus, right? We can get that net area using our antiderivative. Okay, so what you're going to learn a lot in Calc 2 is some techniques for antidifferentiation. So we can get that net area that we wanted by using the antiderivative f of 3.5 minus f of 2. Now notice, no matter what my c would have been, if I would have moved this blue graph, so the blue graph is big F. We were calling it velocity, of course, before. But if I move that up and down, the change, and that's all we're talking about with the change in net area as we go from 2 to 3.5. If I move the graphs up and down, it does not matter. If I had any plus c here, right, I would have gotten the same value of negative 60. I won't go into a lot of details there. I'll let you think about that. But that's the fundamental theorem of calculus. We can get the same value, the same net area, by taking the antiderivative, f of b minus f of a, where big F is the antiderivative of the function we're given, little f. Hope that helps.